Hi, my name is Foad Alavi, and in this video we are going to talk about Docker. What is a Docker file? How to create an image and how to run a container. After that we are going to talk about how to containerize one simple console application. And at the end of this video we will understand how to use Docker Compose to containerize a whole solution using SQL Server, Web API, and UI project. Then stay tuned. First of all, you need to install WSL on your Windows 10 or Windows 11. I will put the link to the documentation here below inside the description. You need to install it. It is a light version of one Linux distribution on your Windows 10 or Windows 11. By default, Windows 11 and Windows 10 after a build, I cannot recall the build number, they have the capability of having an embedded Linux distribution there and you can use it. And then you need to install the Docker Desktop on your Windows machine. Docker Desktop gives you an experience like that. It has some tabs, containers, images, volumes, and some other things. We are going to explain them in details. Let's see it. The best way to understand Docker and containerization is to understanding the virtualization, because they are both here to address the same need. They are here to give us the ability to have more than one running machine on one hardware. How? Let's see it. Imagine that we have a host infrastructure. It can be your laptop, your PC, a server, or a server on the cloud. It has a RAM, it has a hard drive, it has a CPU, and you have some network adapters there. After that, you need to install one operating system on the host. I'm calling it host because it is the terminology that we use in the virtualization. It can be Windows, Linux, or Mac OS. On top of that, for creating a virtual machine, we need to install a hypervisor. Hypervisor is something that shares the hardware of your host. What hypervisor does is to create some virtual machines for us, and each virtual machine itself needs to have operating system. Then you need to install your beans or libraries. As an example, you can install SQL Server, you can install Kafka, you can install RabbitMQ, and then on top of that you need to install your application. The dependencies for your application needs to be installed. The application should be installed. The operating system should be installed. It is really heavy because you have an operating system on your host and another one on your guest. Virtualization using VMware, using Hyper-V, it was just a way to share the hardware between different operating systems and environments that you wanted to create. But there is another way. The other way is to use Docker or some other applications to containerization. You have an infrastructure. It can be your PC, your laptop, a server, or something on cloud, and they have RAM, hardwares like hard drive, CPU, and network adapters. You need to install operating system on them, Windows, Linux, or Mac OS. After that, you need to have an engine. Here we are talking about Docker engine. We have two types of Docker. We have two concepts in Docker: Docker engine or Docker daemon and Docker client. Here I'm talking about Docker daemon. It is something, it is an application not to share your hardware. It is here to share your operating system processes. And on top of that, you don't need to install the operating system anymore. In reality, you have a really lightweight version of operating system which is running there and you need to install it, but it is not a full-fledged operating system with all dependencies. It is really lightweight. We will see it in examples. You can have installed beans or libraries there, and on top of that you can install your application. Okay, there is something weird here. For these two applications, I can see that libs and libraries are shared. The promise of Docker and containerization is to have isolated environments. But how can we have these isolated environments when we are sharing the bins and libraries? It is because of the mechanism that it has to share different layers in an image. But when you are going to run it and create the container out of that, they are all isolated. How to create one Docker container or Docker image, and what is the difference between Docker container and Docker image? First of all, you need to create a file that we are going to call it DockerFile. DockerFile is just to write down in text and tell the Docker daemon, Docker server, what do I need to have inside my image. We need to build this Docker file, and after that we will have a Docker image. Docker image is what we create out of the Docker file. Depending on your Docker file, it can be really lightweight or heavy. For example, if you create a Docker image for MS SQL Server, it might be up to 2 gigabytes. But if you are creating just one really lightweight web host for hosting and serving HTTP requests and showing just HTML files, it can be maybe 50 or 60 megabytes. This Docker container is something that we store in a registry like Docker Hub or your local registry, or maybe on Azure, and you can run it. By running that, you will have one instance of this image running on your Docker server or Docker daemon. We are going to call it Docker container. Docker container is something that you can run your Docker image and your applications inside that isolated. Let's talk a bit about Docker image and Docker files a bit in more details and see some examples about them. After that, you will understand it better. Just one thing, traditionally Docker images are read only. When I'm saying Docker images are read-only and immutable, and traditionally it is like that because there are some ways recently to change Docker images as well, but let's stick to that and say Docker images are immutable and container is a place that you can change things there. Let's talk about DockerFile. DockerFile contains of a set of the layers that creates a stacked layer, and all layers together make the image. As you can see here, we have some layers, and layers are on top of each other. And these layers are read-only, and each of them has a unique ID. Imagine this one is for MS SQL Server. I'm not really good with writing with mouse. This one is for SQL Server. It is on my machine. I have it there, and I'm going to create another image, and in the other image I'm going to use MS SQL Server layer as well. Docker image is something that you will run, and when you run it, it will be isolated. But before that, when you are going to store it somewhere in your hard drive, you don't need to have 3 or 4 instances of MS SQL Server installed somewhere. Okay, then the reason that we have a shared libs and libraries here is that each layer can be used several times by Docker. Let's jump to code and understand Docker files. For the first demo, we are just going to create one simple HTML file and host it somewhere and containerize it and put it in a Docker image. How to do that? Let's start with creating the file. Let's call it index.html, and inside this index.html, I'm just going to create one simple stupid dummy HTML file. It has a title and it has something inside the body. It is h1 to just show you that Docker for developers, yeah. And then the next thing that we need to create is to create a Docker file. The name should be DockerFile without any extension. It is the convention that you need to follow. Okay, DockerFile. And in this Docker file, I need to explain to my Docker daemon how to create the image for me. But how? First of all, we do not use to create the images from scratch. You need to write from. You need to give it the base image that you want to start building your container based on. Here, we have hub.docker.com. It is something like NuGet servers for you, but it is just for the images, for the base images that you can download and start working on. Here I can go on explore and I will see that we have Alpine. I usually start with Alpine servers. We have so many other things: Ubuntu, Python, Redis, and PostgreSQL, Node, HTTPD, Mongo. There are some base images that you can just call and create your image based on them. In this example, I'm going to use HTTPD server, and just be careful. Everyone can put their images on hub.docker.com. I personally just go for the official Docker official images. Here I can see some explanation. It tells me that if you want to use command prompt and just download this image, you can use Docker pool. Let's try this one. Let me copy it, bring up my Docker, go inside my images tab. There is no images installed here. Let's go to the command prompt and just run it. It is trying to pull everything. As you can see, it is pulling more than one thing because it is pulling the different layers that I mentioned, and these different layers can be used again. Let's go back to my Docker desktop and you will see that we have this one downloaded here and ready to use. Let's remove it. I don't want it for now. Let's go back to the browser, and there are some explanations here. As an example, it says that you can use one of the tags like 2.4. We have a column in front of the name of each image, and we can specify a tag or a version. Let's stick to the name tag. We can specify a tag for the image name. This is the full name of the image name, column, and a tag. We have a convention for using the latest. My suggestion is never use the latest one unless you know what is inside that. Let's see how can we use it. Let's see it. There are so many configurations that we can do. Read the documentation if you want to use it. And it says if you want to run it, you can use this one. We have some other variants of the HTTPD. I usually use the Alpine one. Now we know how to understand the dependencies and the usage of this image. Let's go back to Visual Studio Code and start writing my Docker file. Now that I know it, I'm going to ask my Docker file to get the base image from Docker Hub, and the base image is HTTPD with the tag Alpine. And then I need to copy my file inside this Docker container. Imagine that you have a computer. I'm working on a computer and I'm going to install a Docker somewhere. In this Docker instance, there is an operating system. It has the file structure. If I want to run something there, I need to copy the files that I have on my local machine to this Docker instance, Docker container, and after that, ask that Docker container to run it for me. How can I do that? We have some commands inside the Docker file. One of them is copy. As you can see, it says that copy, you need to specify the source and after that destination. For the source, I'm going to tell it here. I have the current folder, the path, and the way that we are treating it should be in Linux way because I am using a Linux based daemon. And this one means the current position that we are in. And after that, I'm going to ask it to copy a folder somewhere else. Let me add another folder here and call it HTML and place this one in it. I really don't want to have my Docker file exactly in the path that my HTML file is. And let's tell everything inside the HTML should be copied to a destination. Inside the documentation of the HTTPD, we saw that we need to copy everything to user local Apache to HTTP docs. Let's save it. Now we have one Docker file. How to create an image out of that using the build command. Let me open the terminal here. Okay, we have the terminal opened here. Let's see first, where is my path? It is in Docker folder. Docker folder is here, but I want to go inside the demo Docker file. Let's do it, cd demo Docker file, and let's check what files and folders do I have here. I have a folder for HTML and I have a file for DockerFile. How to build this one? It is really easy. Let's call Docker and I'm going to build it. Then the command is build. I'm going to give it a tag or name -t. I'm going to call it HTML demo column 100. Be careful. I guess we cannot use the uppercase letters inside the tag name. It is what I read many years ago. I never checked that after that, but I stick using all lowercase namings for the tags. We can specify the Docker file location inside your hard drive, because Docker file location is exactly where I'm running this command. I don't need to specify that, but for example, imagine that we had Dockerfile inside the HTML, then we should say .html with tag f to specify the path for the Dockerfile. And the most important thing is a dot at the end. This dot is first of all, let me add something before that. Everything inside the Docker, because I'm using a Linux-based daemon, all the paths, all the addresses that we have is based on Linux addressing, which means that when you are passing a dot to it, it means that my running folder is exactly the folder that my command is running. Here, dot means this address. We are passing this address to the Docker engine, and then it is going to look for the Docker file here. Yeah, I guess it is all. And let's run it. It is going to first check if we have this image, this base image available on our machine. It is going to pull it from our machine and create a layer on top of that. If we don't have it, it is going to look for it on online repositories, and the first repository it is going to check is Docker Hub. Let's go to the Docker desktop and see it. Yes, we have this HTML demo with this tag. It doesn't have any status. It is created 5 minutes ago. Why 5 minutes ago? It was just 2 seconds ago, and the size is 59 megabytes. And as you can see, if I refresh it here, it says that I have just one image, and the total storage that it occupied is 9.11, exactly the same thing that I have here. It will be fun. Can you remember that I told you that different layers can be used multiple times? Let's change our code. Let's go back to the HTML and create another thing here. For example, the second version. I'm not really good in namings. And let's run our command again. I am going to create another Docker image based on the changes that I had in my file. Let's run it. I just changed the tag name to 101. Let's see what will happen. If I go back to my Docker desktop, I will see that I have HTML demo with tag 100 and another HTML demo with tag 101. And each of them, they have 59.11 megabytes of size. But if I refresh it here, I will see that I have 2 images and 59.11 megabytes. Why? Because the only changes inside these files were some bytes. I just added maybe less than a kilobyte here, and the rest of the things here is use the existing layers that I have on my machine. It is really nice. I have no container running. Let's go back to console and check some commands. We have Docker images. If I click on Docker images, I will see the list of all my Docker images. And we have Docker PS. When we run Docker PS, it is going to return all the running containers that we have on the machine. Let's try to run them. For running that, we need to use Docker run. Oh, not here. Inside the console, Docker run. I need to specify a name for the container that we want to have. As an example, I'm going to specify -- name, and for the name HTML or maybe version 1. And then you need to specify the port. Inside my Docker container, this web page, this HTML file is running and served on port 80, but I cannot get it using port 80 on my local machine because port 80 is reserved for HTTP requests. Then I need to map a port from my local machine to a port inside my Docker container. The port that I want to use, first of all, the command is -p. The port I want to use on my local machine is 8080, and after that, the port that I want to map to it and bind to it inside the Docker container is port 80. When you are working with Docker, everything is like that. We had copy here, copy. The first address was from the host, my computer, my laptop, and the second one was inside the Docker. Here as well, the first port is for my computer, my laptop, my server, and the second one is for the port inside the Docker container. And at the end, you need to specify the name of the image that you want to create your container based on, which was HTML demo version 1.0.0. Let's run it. Fine, it gives me some errors. I guess it is about certificates or something like that because I didn't pass the configuration here. I don't care. Let's go to the Docker container part, and you can see that I have a container with name v1 from image HTML demo 1.0.0, and the status is running. And about the ports, it says that you can have access to the port 80 of the container on localhost port 8080. Our images are here. The status for the image that I'm using changed to in use. Can we run another one? Can we run another Docker as well? Yes, we can. But as you can see here, my terminal is attached to the process that I created. And by pressing Ctrl+C, I can use my containers. I can use my console again. If I go back to the container path, I will see that this container is not running anymore. It means that my console is always attached to the running container. If I want to get rid of this attachment, I just need to add a switch to my run command. We just need to write exactly the command that we had and add one -d here. Let's run it, and oh, there is a conflict here because it tells me that you are trying to run something and create a container for something that you already have with this name. Let's delete this one and run it in detach mode again. You will see that it is the ID of the container that I'm using. Let me open Docker desktop. You will see this one is running, but how can I see what do I have here? Just by clicking on it, it redirects me to localhost port 8080, and you can see Docker for developers. Nice and easy. Let's go back to my Visual Studio Code and try to run it. This time for the version 2, I'm going to call it version 2, and I'm going to call it for HTML demo with the tag 101, and let's run it. If I run it in the attach mode, okay, let me see what it says. Fail externally v2 blah 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 blah, because this port is occupied. Yes, correct. I need to change the port because on my machine the other container is running and using port 8080. I need to use another port. Here I'm going to use port 8081. Let's run it now. Okay, come on, it tells me that v2 is running because it tries to run it but couldn't execute this one. Then let me remove it and run it again. Okay, everything is fine. Let me go back here and try to run it on port 8081. You can see that I have two environment, I have two ports, I have two containers and running side by side. The reason that I wanted to run this one in attach mode is to show you that there are some useful informations here. For example, the server received a GET request. The status is 200, and I guess served 228 bytes back to the client in the request. I guess it is the easiest thing we can do with Docker. Let's talk a bit more about the different commands that we have for the Docker files. Let me press Ctrl+C to detach this one and close the console and go back to the Docker desktop. Stop everything. Stop it first and then remove everything. We have some commands for it. For example, we have some commands for removing images, removing containers. I'm not going to cover them here in this course because you can learn them easily just with searching them online. Let's go back to the commands. We saw that we have from. We have copy as well, to copying something from your own laptop to the Docker container. And after that, we have a command for run. Run is a command that you can run, but be careful. As programming that we have compile time and we have run time. When you are creating a Docker image and Docker container, we have a build time and run time. Run command will run in the build time. It means when you are creating your image out of your Docker file, then this one will execute at that time. And we have another command that we can pass to it, which is cmd or command. You need to pass a command to it to execute something, and cmd does exactly the same thing that run does, but in the time that your container starts running. Then run is for build time and cmd is for the time that you run your image and create the container out of that. Yeah, it's a bit confusing. And there is another thing about cmd. You can specify just one cmd in your Docker file. Maybe if I want to put it more accurately, you can have multiple cmd in your Docker file, but just the latest one, the last one, will get executed. We have another command here, which is working directory. You can set a working directory inside your Docker container. As an example, you are creating an image and you want to switch between one folder to another folder, and switching always is not that easy. Then you need to tell it, okay, my working directory is this one. From now on, all the commands that I'm going to execute it should be executed in this directory. We have an endpoint. Endpoint is almost exactly the same as cmd. We are going to specify that when the container is up and running, what I want to execute there. And we have another thing. We have, as an example, volume command. You can use volume command to specify the volumes that you have. Volume is just a technique to share a path between your laptop, not between really your laptop, between your server, Docker server, and your Docker container. What do I mean? Let me open it. As you can see here, I have Linux installed here, and if I click on it, I have two shared folders, one Docker desktop and the other Docker desktop data. These are the shared folder that gives me the access to the daemon, and we can see that what is getting shared between the container and Docker server or daemon, and we can put files here. We will use it, you will see it in the examples later. We use volumes a lot, but be careful when using that, because volumes is the only place that you can save your files. Docker containers are not like virtual machines. If you create something on virtual machines, the virtual machines will keep running, and if you turn them off and turn them on, they save the last state that they had about the files, about everything when you shut them down. If you create a file inside the virtual machine, shut them down, the next time that you run them, the file is there. But about the containers, if you run a container, add a file there, or maybe create a file there, you turn it off and turn it on again, everything is gone. It is just a clear container for you. If you want to persist something, you need to use volume to map a path inside your container to somewhere outside of your container. It's a powerful way to do that. There is another command. This command does nothing. Expose. Expose is just for declaring that, as an example here, I can say, okay, my application, my HTTPD will expose my application on port 80. It is just a metadata. It is just for you to just review it, and when you are going to run it, see what port should you bind. Fine, let's have a real example and create a real Docker file for a console application. I do have a console application and I'm going to Dockerize it. How? Just by adding a Docker file here. Let's add a Docker file. And this Docker file, oops, it shouldn't be .cs. Yes. And here I'm going to type from. But from what do I need to create this Docker file? From a base image that Microsoft provided us. From. Yes, and it is from Microsoft repository .NET SDK version 7, because I need to have .NET SDK to build something. For running that, I can use .NET runtime, but for now we need .NET SDK. As you saw, writing and editing the Docker file inside Visual Studio is not that straightforward. Then let me go back to my Visual Studio code and change it using VS Code, because inside the VS Code I have a lot of extensions here. One of them is Docker. It helps me a lot, and I guess I have something else installed here. Let me check my extensions. Do I have something for Docker, or it is just this one? No, I guess it's just this one. This extension makes the life easier for me to write Docker files. I'm getting the base image .NET SDK, and after that I want to create a working directory. I'm going to say I am going to work on src folder inside my container from now on, and I need to copy everything from my local machine to the Docker image. How? I'm going to run the copy command. Let's paste the code here from the console application project, everything to console application. I had the code prepared, and in the preparation it was console application 1. Now I just renamed it to console application, and it is the reason that I am modifying what I'm pasting here. And then I need to run the restore command just to be sure that all the packages I have here for this project are restored inside my Docker file, inside my Docker image. We have one console application folder inside my Docker container, and I am going to run the .NET restore command for this CS project. After running this line, we copied everything to this folder. It means that it is going to create the console application folder inside my Docker container. To understand it a bit better, let's rename it to inside Docker, because we have a console application here as well. Yes, run .NET restore inside my Docker, and because it is run, it will get executed at the time that I'm going to create the image. And then when I restored it, I am going to copy everything. I am going to copy everything from my address that I am in. What is my address here? My address is the console application. Because this Docker file is inside the console application, I'm copying everything from my console application to everything inside this path that I have inside the source. Okay, fine. We just copied the CS proj for the first step, restore just based on the CS proj file, and now we are copying everything. It is time to set the working directory again. I'm going to set the working directory. I changed the name. It should be source/ConsoleApp inside Docker. And now it is time to run it. I guess it is time to run it. Before running that, we can run some other commands here just for the sake of the demo. Maybe I can run these two commands as well. We are going to publish our console application project in release mode and publish it inside the source-publish. Use this command and then change the working directory from source to publish. And finally, we need to set an endpoint or pass a command cmd to my Docker container, and endpoint and cmd command will run when you are starting your container. It is going to tell my container operating system, which is a lightweight Linux operating system, run .NET command and pass this argument to the .NET command. It is going to run .NET for this file that we created there. Let's see it. It is the command that I have. It is the .NET file. Now it is time to create the image out of that. How to do that? I can just open a new terminal here. Let's go inside the application, console application. Let's see, what do we have here? We have console application folder and console application solution. Because all the addresses that I gave it here are outside of the console app folder, it is better to stay here and then run Docker and create Docker image from here. Otherwise, you need to mix with the contexts. How to do it? Docker build it. I am writing in a wrong place again here in the console. Docker build it for me. I'm going to give it a name, and the name for the image will be specified using T or tag. Let's call it console app version 100. And what else do we need? We need to specify the path for the Docker file that we have, and DockerFile is inside my console application, or ConsoleApp is inside console app folder. And finally we need to pass the context that Docker daemon is going to create my image based on. Let's run it and see what will happen. Okay, it fails. It says that it cannot find the Docker file. Let me run it again, but this time specify the Docker file name as well and run it. I will face another error here. Let's see it. What is that? Where is my error? Okay, it says that in the stage that it wanted to run .NET publish and ConsoleApp -cs project using this one, something goes wrong. Let's see what it says. What can I do with this issue? It says that everything is fine until this part, and after that it says that it cannot find the main method to publish it. There is a way to debug it. Let's comment out this line of code and try to build my application again. This is the command that I want. Let's run it, and done with no issue. And now I'm going to just run this one. I built the image, now I'm going to run it. Docker run. What was my image name? I forgot it. Let me just copy it here and paste it. But before specifying the image name, I'm going to tell it I want it to be run in the interactive mode, which means that it is going to run this Docker container and attach my console to the bash console that I have inside my Docker image. Let's run it and see what will happen. Now my console is attached to the source/console_app inside Docker. As you can see, the working directory is here. The bash file is pointing at this. Let me see what file and folders do I have here using command ls. Yes, it is correct. My program.cs file is not placed here inside the folder that I have. Let's go one level higher and then see what I have here. I have ConsoleApp, ConsoleApp SLN, and I have console in ConsoleApp inside Docker again here, which means that my copy command here didn't copy everything really well. Let's see what is the reason. Here I'm copying everything from my folder structure inside to the ConsoleApp.docker. We restored everything, but what I can see here is that I have a console application here, which means that I restored everything that I had inside this folder and then copied this folder, and I'm trying to publish this folder. Confusing? For solving that, it is better to copy everything from console application to console app. The folder that I have here, copy everything to my console application inside Docker. Let me just see how can I do that. Let's say I don't want to be attached to the bash inside my container. Using exit command, find, let's clear the screen to make it more readable. Let's go to the Docker. I have a container here. Let's remove it. I have an image here. We can remove it or not, I don't care. Before running the command, let's check if it is correct or not. This is ConsoleApp. Yes, this is ConsoleApp, and here it is an issue because we are using Linux operating system. There is a difference between ConsoleApp with capital C and a small c. Let's run it and see if it works or not. It is trying to build itself. I guess it is working. If I go back to my Docker container, I will see that I have a container named ConsoleApp with tag 1 and without any status. If I just run it, yes, please run it for me, I will see that it printed out hello world, and after printing out the hello world, it shut down itself. Because as I told you, there is a difference between the container and virtual machine. Container does what it needs to do and shut down itself, but virtual machine, you need to specifically shut it down. Okay, fine, we learned how to do that, but let's go back to my image and see the size. Oh my god, it is occupying almost 800 megabytes, which is a lot for just one simple stupid console application. I don't like it. Let's rename this file to something else like .back, .back, BAK without C, yes, and go back to my Visual Studio. Inside the Visual Studio file, let's remove this one, save everything. Why it is not syncing itself? It doesn't have the Docker file anymore. I don't care, because it should be Docker back. Come on, Docker back. Let's save it. Now we can see it again, but Visual Studio from Visual Studio 2019, I guess, added a really nice feature. You can right click on the project, go to add, and add Docker support. By adding Docker support, you need to specify what is your operating system. My target operating system is Linux, and by pressing OK, it is going to create a Docker file for me. You can trust it most of the times, but not always. As you can see, it is downloading the base image. It is exactly like what I had. Let me open my file. Let me open my file, this .back file, and place it here side by side. The from is exactly the same, but it is going to call it base. And after that, change the working directory to app. The folder doesn't matter. The only thing that matters to me now is that as base. Why it is important? Because it is giving some stages to this run. For building the application, I need to have .NET SDK. Fine, .NET SDK is heavy, almost about 800 megabytes. But for running the application, do we need to have .NET SDK installed on my machine? No, .NET runtime is enough. Oh, and I mistakenly said these two lines are the same. Here I am just getting the .NET SDK. Here we are getting the .NET runtime. We created one layer for .NET runtime, one stage for Docker runtime, and called it base. After that, we are running exactly the same thing, almost exactly the same thing that we have here. We are telling it to get .NET SDK, call it build stage, working directory is source, copy everything from my current project to the destination and restore it. And after that, changing the working directory to console application, and then we are running and building our application. Then we are creating one stage and call it publish. But instead of using one image, we are using the stage that we have. We are creating this publish stage based on the previous stage that we created here, that we had our application built and restored. We are just publishing the code that we have inside that stage and place it inside app-publish. And then we are running the final stage from my base stage, which means that in the base stage, I have just .NET runtime installed, not SDK. SDK is heavy, runtime is lightweight. And it is changing the working directory to /app and just run my application. Oh, before that, it is copying the publish folder, and publish folder is getting copied from the publish stage. You know, in the publish stage, we placed everything inside app-publish. We are copying everything from the publish stage, from this address app.publish to the current location that I have, which is /app, and after that I am running my .NET. Let's run this command and see what is the difference size-wise between these two images. Let's clear the screen and let's build this image, and let's give it the name console application 1 and just run it. Hopefully it will run really fast. It fails because it cannot find the Docker file, because as I told you, it is using the Linux naming system. We have Docker file with capital D here. Let's run it again. Docker with capital D and run it. Let's wait for some seconds and see what will happen. Yes, it is running, and it is running fine. Oops, this is an error. This is an unexpected one. All the errors that you see today, I designed them to teach you something, but this one is unexpected. It says that it is trying to build my application, but there is something wrong with my CS project file. Let me go back to my CS project file. CS project file. I guess the issue is with this back file that I created. Let's just comment out this line of code and go back to the Docker and run the command again and see if it works or not. Let's give it some seconds. It is working fine. Fine, successfully done. And now I can see that I have one console app with tag 101 and the other one with tag 100. The difference between the size that they have, one of them is almost 800 megabytes and the other is 190 megabytes. It is huge. Using this staging technique, you can achieve the goal to occupying less size on your hard drive. And as you can see, Microsoft .NET runtime is installed here as an image. I don't know why, but sometimes it happens. Let's remove all the containers and all the images here and see how can we use Docker and containerization in a way that we can have isolated environments for a huge application. In my scenario here, I prepared an application. We have an school UI. Inside the school UI, I have a service, and in the services, I am using HTTP client factory to create an HTTP client and send some requests to my API application. In the API application, I am sending the request to a database, and I have a database installed on my machine. But what if I want to Dockerize everything? What if I want to have one Docker container for SQL Server, one Docker container for Web API, and another Docker container for my school application UI? How to do that? First of all, let's run the application. Let me see, because the application is almost dependent to each other, some parts of that. I'm going to start the school UI and start the school.api without debugging. Okay, let's run it and see what will happen. It is running them. It runs the API using the Swagger, and it runs my application. Let's go to the students part. Great, I can see it. I can add a new student as an example. test1, test address, and today as the birthday. As you can see, it is added here. Let me delete it. If it deletes, yes, it is working fine. Then I can say that my application is working and everything is fine. Now let's Dockerize it. Inside the Visual Studio, if I can find it and open it. Yes, inside the Visual Studio, let's close everything. I'm going to right click on my web API and go on Add and create a Docker support file for Linux. It is the first thing. Yeah. As you can see here, it is not only copying the NuGet config that I have here, but also it is copying the API and domain, because the API project has a dependency to another project which is domain. This project, this solution is not domain driven, is not service architecture. It is just a simple sample for understanding the things better. Fine, it is telling me that it is exposing everything on port 80 and on port 443. Let's go and check everything inside the properties, inside the launch setting. In the launch setting, it added a Docker launch profile with the scheme, with the service host, with the port and Swagger. Fine. And as you can see here, we don't have anything configured for HTTPS. Let's go to the program.cs. Inside the program.cs, I don't have anything specified for HTTPS as well. Then why we have this port here? I don't know, I don't care. Expose is just one metadata. We are not going to use it. For the other one, for the UI, I'm going to use add, but this time instead of using Docker support, I'm using to use container orchestrator support. I'm going to use Docker Compose and click on OK. And then it asks me, okay, you add a Docker Compose. Docker Compose is responsible for running more than one Docker file, create the images, and then run the containers. And it can be sure that, for example, if one container has a dependency to another one, the one which we have dependency to will bring up and run first, and after that the other container will run. Nice. Docker Compose, you will have it installed by default on your machine if you are installing the latest version of the Docker desktop. And here I'm going to tell that my UI project will be hosted on Linux as well. Yes. It created one Docker Compose project thing for me. Inside this Docker Compose, we have a Docker Compose.yaml file, and we have two Docker Compose files. One YAML file for the UI, and we have UI inside that, and the other one for override. I will explain them in details. We have a NuGet config file here, mainly if you are working on home, on your local machine at home, you don't need to have it. But if you are working in a company, and in the company you don't have access to the I don't know, NuGet packages servers, or maybe Docker Hub, because you have some internal repositories, Nexus repositories, and for being compliant, you should use them. You have to specify the package sources here and let the Docker file to copy this NuGet config as well to your Docker container and start asking for the packages from this source. Otherwise, you will face an issue. I'm not going to remove this one. Let's have it here. But because I don't have any Nexus repository or things like that here, I'm going to comment this line for both Docker files that I have. I don't need it. I have two Docker files, and Docker Compose is responsible for running them for me. Inside the Docker Compose, you need to be careful. Let's switch to the Visual Studio Code because it is easier inside Visual Studio Code, I guess. Let me find it, Docker orchestration, and I will put the GitHub link for this project and this solution. You can download everything, don't panic, it is really easy. Let's run them side by side. Fine. And I don't need to have the terminal here. This one is Docker Compose. In the Docker Compose, first of all, you need to specify the version. The version that I'm using is 3.4. After that, you need to specify the services. The first service that I have is a student UI. As you can see, I have it inside my Docker Compose and Docker Compose.override. I'm going to tell it, yes, I'm going to have an image, and the image is inside my Docker repository, and the name of the image will be school.ui. Maybe I'm going to give it a tag as well. I'm going to have a school.ui with tag 100, and then I need to build it because we don't have this image in my repository or somewhere else. The context is dot. Can you remember that when we wanted to build something, we put a dot at the end of all the commands for Docker build? It was the context that we passed to that. Now here we are going to say the context is dot, and this dot is pointing at the current location that my Docker Compose file placed. And it is going to create a Docker file. It is going to build this image based on this Docker file. The place is school.ui, and after that DockerFile. We have some other environment things. For example, here we can use the ports to map the ports. You need to make decision about the port of UI and API. Let's think about that like that. I'm going to have access to port 8080 for my UI project and 8081 for my API project. And it is adding some environment variables to my Docker container when I am running it. These variables, in this environment variables, are really useful because they can override some of the settings that you have in AppSettings JSON and some of the launch configuration that you have in runtime. Why they are useful? If I go back to Visual Studio and just for the UI go to the application setting.json, it is not changed, but here inside for the development environment, I am pointing at the base URL that I have for calling my APIs, and here is localhost on port 5100. We can change it on runtime when we are launching our Docker images using the Docker Compose without changing this configuration. And the magic happens using the environment variables. How can I do that? I'm going to tell it that I have one service-based URL, and inside that I have an API, and I'm going to call for something else. Let me do it here. I'm going to create another one. Be careful. Docker Compose is really sensitive about this indentation. It is like a Python. You need to press a tab before each line. You will see that later. But here I'm adding another environment. In this environment, I'm going to tell it I have, let me copy it really fast. I'm going to tell it I have one server's base URL, and I need to press two underscores, the first underscore and second underscore. It means that we have one variable inside this configuration. As you can remember, it is service-based URL, and inside that API. And I'm going to assign something to it. As an example, maybe HTTP something. I still don't know the URL or the name of my API server, but I need to add it. How to do that? I'm going to add another service. I need to press a tab because all services should be in the first tab. I'm going to call it a school.api. Fine. And after that, I'm going to specify the image for that. Let's copy it and paste it here. And for the image, I'm going to call it a school API with this tag number. And for building the image out of the Docker file, I'm going to tell it I have one school.api and DockerFile stays there. We have one service for school UI and another service for school API. Now I'm going to point to a school API from a school UI. Then here, without specifying anything, I will say that overwrite the address for the API with the school API. Behind the scene, .NET Compose is going to create something like a network, a virtual network behind the scene, and place all your servers inside that network. It means that all the services that you have here can see each other and communicate to each other using the name of the services. It is an awesome thing because you don't need to specify IP addresses here. And it is double awesome because you don't need to change the configuration inside the application. You just need to pass the variables to that. Okay, let me save everything. Let me save these two. And now I need to have some other environment variables for my school API. Let me see what do I have here. If I go to the school API, in the launch configuration, I don't have anything that I want to change, but inside the application.json, I have connection string, and I really want to override this connection string inside my Docker Compose file. Let's see how can I do that. Here I'm going to tell it that I have another service, which is a school API. School.api, yes, and I am going to overwrite the environment variables for it, and it will be something like that. Oh, let me remove it. Connection string double underscore default connection string, and then server equal school DB. Here in my Visual Studio, I'm pointing at local DB, but I want to point at a Docker service, Docker image. Here we call it service, and I'm going to call it school DB, and reading everything from a school database and using SA. Okay, let's see how can I create this school DB. I have the code prepared here. I'm going to create a service for schoolDB, and this schoolDB is loading an image from Microsoft MS SQL Server, which is run on Ubuntu. I'm going to give the container a name like a schoolDB. I can specify a container name for all of them because I just specified the name and tag for the image. I can specify a container name as well. Let's change it, for example, here to maybe UI and API. It is nicer because when we run it, we can see this name in the container list. And we need to pass two environments here. First of all, these are necessary for running SQL images. SQL SA password, it is password something. Yeah, it is the base password. And these environment variables are related to licensing, I guess. I'm not sure, but you have to pass Y, which means yes, to this one. And let's just configure the ports that we want for our SQL server. We are going to map our port 4033 from our local machine to port 4033 from the Docker container, which we have SQL server inside that. And here we can have ports, and for the ports it is better to map it 8081 to 80. You need to make decision. You can call it, I don't know, 8085, but you need to be sure that the port is open and is not used on your machine. Let's see if I need to add anything else or not. There is a thing. there is a reason that I am adding environment development here, because inside my application, if I go to UI, inside the app setting, I don't have the URL for the API servers. I have it inside my app setting development.json. It is not really a correct way to specify it. It should be placed inside the app setting.json, but for the learning purposes, and because I wanted to show you that you can override not only the app setting but also the app setting.environment's name using the environment variable that you are passing, I did that. We are overriding something on app setting.development because the environment variable that we are passing to our application is development. And for the API, we are not passing anything to that. It means that it is not the development environment. Then it is going to override the app setting.json. Do I need to add anything else? Yes, we can. As an example, we have some variables for launch files, for launch configuration file. In the properties, we can say that it is going to run on port 80 and this one is going to run on port 80 as well. I guess we are fine to start using it. How? Let me open a terminal, and inside the terminal, let's say I'm going to go to the Docker orchestration. And inside the Docker orchestration, I am going to use the command docker compose up. Here I'm going to run docker compose up. By running this command, it is going to look for all the Docker files that we have, create all the services we mentioned here and place them in different image files, and then after that run it for me. Okay, a docker compose override must have ports. Fine. Let's close this one and see. Okay, here I can see that I missed one space. As I told you, indentation is really important for this Docker Compose, and let me run it. We will face some issues, but it is nice to see that. Let's run everything. It is trying to pull everything and run everything. Let's give it some minutes or maybe some seconds because it needs to install a SQL Server and it is almost 1.5 gigabytes. Let's wait. Okay, now it is completed. I'm trying to create my containers for me. Let me go to the Docker desktop application. Inside the image, I can see that I have my MS SQL Server, I have the school API, and I have the school UI. We have some meaningful tags for them. If I go to the container, I will see that my containers are under a category which is called container orchestration, my project name. We have a UI container, API container, and a school container. And the API container, it couldn't run itself. Why? The reason is that here we didn't specify, let me close it. Here we didn't specify a password. Let me copy and paste it from here completely. Yes, we have the password, and because you are running your SQL Server on Linux, you have to specify the trusted service certificate is equal true. Otherwise, you cannot use the SQL because it is a Linux-based SQL Server. And you need another thing as well. There is a reason, I'm not sure if I can show it to you or not, but inside the API, when we try to create the API, inside the program.cs, we are going to see our database. But what if my database container is not up and running when we want to run it? For being sure that the container is up and running, I need to add some other switches to this Docker Compose. For example, for the API, I'm going to tell it that it depends on my SQL DB, and for the UI, I need to tell it that it depends on the SQL API. It means that before bringing up this container and run this container, you have to be sure that SQL API is running. For running SQL API, you need to be sure that SQL DB is running. And by doing that, we don't face these issues anymore, hopefully. Let's go back to the terminals again. Let's press Ctrl+C. By pressing Ctrl+C, the containers get stopped, as you can see. And we have a command. What happened? Yes, we have a command, Docker compose that's down. By writing that one, it is going to delete all the containers for me. Images are here. If you are going to change anything inside your code, not the Docker compose file, inside your API code or UI code, you need to remove them, because if you have them here, it is not going to build your application again. Be careful. And let's save everything, save the changes that we made, and run Docker compose up again and see what will happen. It will be really fast. Let's go to the Docker compose. Let's go to the containers, and as you can see, it is up and running. I wrote a part of code here just for testing it. Here inside, when I am adding the DB context to my services for being injected using the dependency injection, I'm just writing the new connection string that I get from the configuration. Let's check it inside the Docker. Inside the Docker, I can click on API and I will see the logs here. And if I scroll up, I will see that the overwriting of the connection string was successfully, because it is pointing at the SQL DB. And I have exactly the same thing here. I have the same thing for UI as well. UI is pointing at HTTP SQL API. And if I click on HTTP SQL API, I can see nothing. But if I click on this link, which is mapped, it should run. It is for API, it should be /swagger. Come on, what I'm doing wrong? It is for API, it should be /swagger. Oh, sorry, we cannot run it because the API is not in development mode, and Swagger will run just in development mode. For testing our application, we can just use the UI. If I run the UI, it is running on port 80, as you can see. Yes, and if I go to the students, I will see the students here. I can add a new student here. As an example, test address, and with this birthday, and we can add it. We can edit this one, add a 1 at the end of all of them. Yes, it is working, and delete it. Fine. Using Docker and Docker container, if you want to have one isolated environment for each of your applications, is really fine. You can use them in your daily life programming. It will save you a lot. For example, you don't need to install everything on your machine. You can just install a Docker desktop and bring the Docker image up. As an example, Redis, RabbitMQ, Kafka. Some of these applications, they have a lot of dependencies and they make your computer polluted. And even if you uninstall them, some services in background will running and check them. Use Docker. Use Docker Compose and try to follow the best practices. You can enjoy using it and writing code using Docker. If you like this video, please subscribe to my channel and like this video and hit the bell. By hitting the bell, when I upload a new video, you will be notified. And please let your friends know that my channel exists. It means a lot to me. If you have any kind of questions, you can just ask me using the comments, writing a comment below, and I will push this source code to my GitHub account, and I will place the URL here in the description. Enjoy using Docker and take care.